thank you so much for coming to my talk. As you can see from my title and all the words I jammed into it, I'm really excited to share with you guys the things that my team is experimenting with. But before we start off, a little bit about me. So this is my first time speaking at any tech event ever, and what better first experience. And what better first experience than a Ruby conference that's single-tracked and in front of the father of Ruby. So super excited. And about me, so I'm lived in St. Louis for a long time, and we're the city that proudly brought you Nelly. We brought you the St. Louis Cardinals, and that's St. Louis Cardinals with Nelly. And recently, this blew up on Twitter of how we vertically cut our bagels. I think this is normal. Anyways, now I live in the beautiful city of San Francisco. And after watching Kelly's talk on breaking a monolith yesterday, my biggest takeaway was I needed cute dog pictures. And Greta's not the only one. So this is Sobi living her best life. Speaking of living best life, I work at a company called Square. And Square, you might recognize us from that thing you plug in your phone to take payments. And as the years go by, we've grown our product line to the Stand, Terminal, and this is the premium product that's all in-house software hardware. What you might not know is we have an entire ecosystem that empowers sellers to grow their business. So we do appointments, invoices, et cetera, et cetera, et cetera. And this has a point to it, which is, not just Square, all businesses, as we grow and mature, we enter more markets and our scopes widen. So us as engineers, we have to make sure that our application can scale at the rate that the business goes. And so with Square, we actually have the extra layer, which is we take on a lot of risk. Our baseline product, we give away for free. So in order to manage our day-to-day operations and to make sure we're not facilitating illegal behavior, we have this control center that's used to monitor every operation in Square, all right? So we actually don't store our data in a database. We fetch our data from services that are owned by the individual product teams. And then we have, REST APIs that then we fetch the data from, and it populates the individual fields. So you can imagine as years go by, this gets incredibly rigid. Today, our application is a monolith with 273,000 code lines of Ruby and growing every single day, 22K lines of YAML, 200 controllers talking to over 150 internal services. So with that, we looked for a solution in GraphQL. I think GraphQL is at a point where most people kind of know about it, but they don't really know exactly how to implement it. And similar to how REST is a set of ideas for fetching data, GraphQL is a completely new set of ideas where instead of having your server being resource-based, your server is responsible for modeling your backend data like a graph. So basically, you're going to have a schema. And then the client has the power to query whatever it wants as long as it's within the realm of the schema. I mean, you can just tell by the name where it gets its inspiration from, right? So it's basically like a database query, except your resource is not your DB, your resource is your server. So let's just look at it by example, right? So here we have a REST call with a verb and an endpoint. And the first problem is just look at this. You can't tell me what you're going to get back. You can tell me what is the sane response, but you really can't tell me the response until you actually fetch the data. And so, okay, this looks reasonable. But imagine a field where we need to see the merchant and a detailed view of his payments. Here we have already underfetched because REST is very much so one endpoint per resource. So you just give them the IDs of the payments associated with it. And then your front end needs to know business logic to, okay, now I need to go fetch the payments. And what if I just needed to display the number of payments? I've overfetched. And so if we look at GraphQL, the first thing you're going to notice is that the request, it's called a query in GraphQL, is that it's much more verbose. And this verbosity gets, just more words, gives the client the power to control exactly what are the business objects it wants, the fields on it, and the shape that it wants that data in. So when you get the data back, it's going to return you an error, or it's going to return you the data in the exact same shape that you queried it. So there's no guesswork on the front end side. I'm not trying to convince you that GraphQL or REST is better. I think for certain use cases, REST is absolutely the right choice. But for us at Regulator, we decided that since our data comes from different resources, our data the queries that we need to make are highly diverse, And most importantly, our data is most valuable because of its relationships. If you think about, okay, this payment's $1,000 and this merchant is a coffee shop owner, on its own, it doesn't make that much of a difference to us, but it is the relationship. Why did a coffee shop owner just make a single transaction of $1,000? That is suspicious behavior, and it needs to be escalated up to the agent to take a look at it. So with that, all the context I just gave you, let me give you a roadmap of what I'm going to go over. I'm going to talk to you about our existing model architecture, so what we're starting off with, and then we're going to write out a GraphQL Ruby API using the GraphQL Ruby gem. Then we're going to see what parts of it we can meta-program away. And finally, I want to talk about how we can maybe see how this API works if we adjust some of our business requirements. And finally, I'll touch on testing. All right, got a lot to get through, so let's get started. So here is Regulators, like bird's eye view, right? So we get all the data, watch this, coming from external services, and then it talks to our backend Rails app, and then we actually have another REST layer that talks to our front-end Ember application, which is what our agents interact with. I'm going to scope today's talk to just this REST layer in the, from the backend to front-end being GraphQL. And before we can go into the GraphQL implementation, I promise I tell you about what we have already. And that's when I'm going to introduce to you the concept of targets. So targets is just a term we use for a wrapper class in our backend. And what this wrapper class does is, okay, data comes from these servers, and the raw data is whatever it wants to be. And once it enters the target layer, we wrap it in a unified API such that it can interact with each other and our backend in the same way. And you know, the way we say is like now, regardless of what the underlying data is, they all speak targets. And that's going to be super useful for us later on. And I do want to show you the code for this. And from this point on, all the code I'm going to show you is a personal prototype of mine. So I've removed a lot of abstractions, defensive programming, and things that would have been necessary in production code. And there's a lot of inlining as well, just so that the core idea is easier to follow. So all targets inherit from target base, and we have a fetch target method that you have to implement right here. And all it does is tells me, how do I get the data? And that is called under the hood in our lookup. And finally, all targets are going to have an ID, so I just chucked it in the base class. Now, this is today's data model, and this is an example I'm going to use throughout my entire presentation. So we have a payment with some very basic fields and associated through a merchant ID to a merchant that has a store name. All right, let's look at a merchant target, and this is pretty straightforward. I put my stub on the top, so it's very clear what data we're expecting to get back. Here's my fetch target data. I'm just some nonsense merchant client that just calls my stub, and then it has a store name, which is just a method off of my target. Now, payment, more or less the exact same thing, except it's a little bit more complicated in that it has an associated target, right, which is a merchant. And since the merchant is already wrapped nicely in a target, we can interface with it with this super nice merchant.lookup merchant ID API. And I did a little keynote animation to simulate how it will look in the console. So we got our payment, we got our target, we get the amount's 100, we got the associated target, and we can get fields off of our associated target. And then the merchant works exactly like how you would expect. So that's pretty straightforward. All right, and it's also, I'm going to shoehorn this in, which is we keep a target module that just keeps track of all the targets we have. And it provides some pretty valuable helper methods that will return us all the targets and allow us to look it up by symbol. So with that, let's create a GraphQL API for what we just talked about. So again, just reinforce, this is our data model. And how does it look like in a GraphQL schema? You see how your data is very much so formulated like a graph. So you enter through your demo schema, so I name mine, and it asks first, is it a query type or a mutation type? It's worth mentioning now that GraphQL is actually, it's typed. So it looks for, okay, read or write, essentially. And I'm not going to talk about write. And so it then decides, is it a payment or is it a merchant? And it resolves each of the fields up until the leaf nodes. And with payment, it needs to also resolve what the merchant field is on there. So here is our query. We're going to keep it to the side for reference. And let's get started. So it enters through a GraphQL controller. And you only get one controller in GraphQL. And the great thing is this controller can exist with all of your REST controllers. So you can have a banks account controller next to your GraphQL controller because bank accounts is on some other REST API. So it works in harmony. The only thing you have to care about is it calls execute on demo schema, where it just takes into a query and your variables. Color showing up? OK, awesome. And then in your demo schema, it's like, all right, is it a read or a write? It's a read. Awesome. So we go into our read, and we ask, OK, is it a payment or a merchant? It is a payment. And the first thing that GraphQL does is it parses. So it checks for syntax errors or just like asking for a nonsense thing. The second thing it does is what we're going to go over here is it does validation. So to further understand validation, let's look closely at these three pieces of information. Based on line 4, it sees, OK, we have an ID of type ID, and type ID is just a string or an integer. Do we have an ID? Is the type correct? And oh yeah, it is required, so we have it, and it's all validates. That's good. So now it's like the top level is good. Let's look inside the payment type, and it evaluates this block right here. And all it does is it makes sure that all the fields are there and correct, and ID amount, they're done evaluating, right? But merchant, we need to look deeper in. So what is this? And now it evaluates this inner block right here, and it says, OK, works out. So this is a valid query. And now that the validation does, it does the execution of fetching the data. And how it fetches the data is it uses resolvers. And what resolvers are is a function that matches the field name. So we have that payment that goes with payment. The cool thing with resolvers is that they are pure functions. So I put my target logic there in line 12, but you can stick literally whatever you want. It could be a Mongo query, a SQL query. It is resource agnostic. So here I call payment.lookup, and you've seen this before. We just plug in the parameter we pass in, and boom, we get our data. So now let's see which parts of this we can metaprogram away. All right, so before we jump into the metaprogramming, right, if we're going to do this, I want to see some benefits. So what are some of the benefits we can get from metaprogramming? One, I want to make sure that despite the metaprogramming, our application is still flexible. We can add, remove, restructure things, and not have it break and give us weird bugs. 2, reduce boilerplate. 3, I want it to be self-documenting. The great thing about GraphQL is it makes your API just innately self-expressive to the point where you can stop duplicating app code in your front end and back end. And 4th, obviously, we want an improved developer experience because our customers are as much our agents as it is. Our customers are the developers as much as the agents are. So I just really want to hammer this home, walk through the flow one more time, which is the controller goes to the demo schema. The demo schema goes to a query type. And then the query type validates using these GraphQL type classes. And then it resolves when it's valid. And then it goes into our target classes to actually fetch the data. So if we look at this, we see, OK, target classes we already have, whatever. These two parts you saw in the run-through, there were like 10 lines of code that were relevant. So the 2 areas we're going to try to metaprogram away is the query type and the GraphQL type classes. It's pretty straightforward with 2 objects, but you can imagine in a production environment we have hundreds, I hope I get the point across, hundreds of objects. And that is what's going to get really meticulous and error-prone. So let's talk about GraphQL type classes. And you may notice something. Ruby is not typed. And yesterday, Mats was saying how he doesn't like type annotations. I have a whole section on type annotations. So these are my target class annotations, but it's GraphQL specific. OK, so this is the priming we need to do before we can metaprogram anything away. So again, here's our data model. Wouldn't it be nice if we could append some metadata onto each class called GQL field annotation, for example, and it just has the knowledge of what type each field should be. So here is what I would like the result. So I call payment.GQL field annotations, and boom, it returns me this hash that maps the fields to a type and whether or not it could be null. And those are the 2 bare bones requirements you need to define, and that's what I'm going to stick with for today. So here is our target class again, and this is what I'm going to add. Watch. So we have our class variable on the top, and I call a method called annotate field, and I pass in a string version of what I want the type to be. Because remember, if we're metaprogramming this away, at line 46, type merchant type doesn't exist yet. So that's why it needs to be a string. And then whether or not it could be null, I just did all false. And I pass in a definition, which is the original method that was on the target of how to fetch that data. And now let's look at how we actually implement it. And before we do that, I need to talk about these are the 2 concepts I'm going to use, which are unbound methods and dynamic methods. For unbound methods, if you think about methods, normally they're associated with a class or with with an object. Unbound methods are not associated with either. However, they can be bound later on to a class so that it can be called. And dynamic methods are just methods that are both defined and named at runtime. All right, so let's take this and let's hang on to it on the bottom for reference. And then let's start defining our class. So we have annotate field. And here, the first thing we got to know, what is self? Self, because it is the receiver of the method call, is just our payment class, all right? And then what is definition? Remember, we passed definition in as the original method. And as of Ruby 2.1, the method just returns a symbol of the method name, which is super convenient for us. And then we can just go ahead and set the parameters that we pass in type and whether or not it can be null. And here is where we start using our unbound method. We need to put that original field method back onto the target, right? So we call instance method definition, which is just amount in this example, to get that method, to get the unbound version. And then we use dynamic methods to define amount, and then just do the original method bound back to self, which is the payment, and call on it. And then now we have been able to successfully annotate our target class without mutating any of its original functionality. So with that bit of priming done, let's generate the GraphQL type classes. And here's how I would like for it to look. I'm going to have an object called GraphQL type generator, and when I initialize it, I'm going to pass in all the target classes that I want to become GraphQL types, and it's going to return me this object. And let me just go on to the next line so it's a little bit more clear. Yeah. So what it does is when I initialize it, it's going to create all of those GraphQL type classes and its fields, and it's also going to maintain a hash of the target to GraphQL type class mapping, just so it's easier for me to access the classes later if I so need, like this. All right. And the two concepts I'm going to use here is the Ruby object model and constants. So in Ruby, more or less, everything is an object, and a class definition is nothing but an object that is instance of the class. And a class name is nothing but a constant that is set to equal the object that is the class definition. And I hope it becomes clear later on. So here we have GraphQL type generator, and we have our instance variable right here, and here we pass in the array of target classes we want to generate. All right, so the interesting thing happens in the each, so let's focus on what's inside. So this is where we create our constant, right? This is our GraphQL type class name, which is just going to be payment type if we go with our example. And then we're going to set a constant in the namespace of types. All GraphQL types are going to be in a namespace of types. It's just how it works. And we just go ahead and we set our GraphQL type class name to a new instance of class. And the parameter that you pass in is what you want the superclass to be. And all GraphQL superclasses of our type-based objects. So I went ahead and I did some semantic highlighting. So you can see how the metaprogramming maps out to the written out version. And I hope this makes it a little bit clearer. So you're like, OK, we created basically the shell classes, because we need all the classes to exist before we add the fields, right? Because in case the field, one of the fields, like merchant, is a GraphQL type, it's going to break if those class names at least don't exist, if those class names don't exist yet. So speaking of fields, let's talk about adding them. So we have to look at what the field really does. And what this field called does is it goes into the GraphQL type class, and it adds to the own field's class variable an entry and a hash where it maps the field to a GraphQL schema object. And it becomes clear later on. So I go like, what's ID? The class of it is a GraphQL schema field. And then I go ahead and I open up the actual value of ID, and yeah, we see it is this GraphQL object. And that's all it does, is it appends the metadata onto the GraphQL type class. And what we're going to use here, well, my choice to use here was class eval. And class eval is this nifty little method that allows us to execute arbitrary code in the context of whatever class we call it on, class or module, but for us, class. So here, we're going to go in our method called add fields to GraphQL type class. And we are now doing GraphQL type class.class eval. So now we're in the context of type payment types. All right? And all we got to do is iterate through each field, and we're going to grab the field type off of it and follow the highlighting if it makes it more clear, whether or not it can be null, and then we just call the original method. And there we have it. I didn't put line numbers next to this because this line of code, so this is what actually calls everything and runs everything that we just generated. And you can put this in several locations. Since I wasn't doing any sort of mutation types, I just put this in my query type file because that was the absolute last place it could be before things started breaking. So now that we're done with GraphQL type classes, which was the hard part, so we're more than halfway done, we can talk about query types. So you see here, I've broken it down to two parts, right? We had the root types, which are the entry points into our graph, and then the resolvers, and just making it extra clear here. So how do we metaprogram away the root types? Well, let's hang on to this for reference. And all we got to do is iterate through each of our target classes, and all we're doing, this is not even metaprogramming, is we're just interpolating the field name through this each loop, and then bam, we have all of our root types defined. And then for the resolvers, it's going to be more or less, oh, I thought it was really funny. It's boilerplate gone. So yeah, that was my subconsciousness trying to skip that slide. And so here we have our resolver for payment. And we're doing the exact same thing. We're still within that same each loop. And we are just going to iterate over this dynamic method call where we define payment. Yep. Oh, there we go. And then here, we grab the target class, and we just call the exact same thing. Payment.lookup is all it's metaprogramming away. All right, with that, we're done. So here, I would like to show you a demo. So GraphQL is a lightweight client that just comes with the GraphQL Ruby gem, which is super awesome. It has some really aggressive syntax checking. But here I am passing in my payment query. And you see how the syntax is very much so you're querying off of a database. So here we have an ID, and it loads up your whole schema when it runs it, so it can do even a little bit of type checking. So it does type checking for you, and to make sure that the fields that you're querying are correct. For example, if I just query some nonsense, it'll show me all the fields that are available, and if you hover over it, it'll be like, why is this broken? Oh yeah, because hi doesn't exist on payments. Now let's ask for something that do exist, which is a merchant. And we want the ID on it, and we want the store name. So this is what the client sends over, so that's why it's camel cased. And then we plug in our variables, 1, 2, 3, 4, which is what I mocked. And we hit run, and boom, we got our data back. And this is a super fast way to test your backend API without having to deal with the backend. So let's go ahead and add and remove some fields, right? I just want the IDs for whatever reason, and it's still good. And think about all the combinations of calls you can make without having to change any app code, right? And that is the power of GraphQL. It's also worth noting that when you're developing, you don't have to pass in variables the right way. You can just plug it in, and it still works. And I'll be doing that for the rest of the presentation. So let's see how it adapts to change. So let's add a new target called card, like a payment card, debit card, right? So here's our old data model. And here's the new data model. We just have a card that links to a payment, right? It has some pretty generic fields on it. And I have my card data right here. It's a little bit more verbose because it has more fields. And it's associated to a payment, and I've annotated it already. And yeah, it just works. So we make sure that our payment is still working, and now we can query for card. So let's first see if we can just get the fields that card owns. So we got ID, name. I type really slow. So that works. So now let's get the associated target, right? A payment. So we can get the ID, get amount. But remember, a payment has a merchant. So can we get the merchant off of the card? Yes, we can. And I did this by just adding a new target, and our metaprogramming took care of creating the card type class and everything. And just think about how many REST endpoints I got rid of, just with this one GraphQL controller. And I want to do some bigger change. Say we have a requirement change where we need to change the structure of our data model. Let's say I don't care who you are as a client. You don't get to just be like, I want someone's credit card information, right? You can only look at a credit card if you have a reason to look at a suspicious payment. And only through the context of the payment, if it has a card associated with it, can you view that credit card. So you can no longer just go ahead and do GraphQL, give me the card. You have to call a payment, and through the payment, you can see the card. And we do that by controlling the root types. Remember, we were iterating through every single one of our targets to create the GraphQL types, but what if we can restrict this to only the valid ones? So we go back to our query types, and just quickly define a root types array. So it's just payment and merchant now, no card. And we're going to iterate amongst those valid root types instead of all the targets. And if we look at our demo, so we make sure that the original stuff still works. If I ask for a card, it's not there anymore. And if I'm like, whatever, I'm going to go ahead and ask for it anyways, I'm just going to grab the ID off of it. I run it, and it's like, gives you a very helpful error message. Field card doesn't exist on type query. But if I go ahead and delete that, and I go back into my payment, which is going through the path of my payment GraphQL type object, we see that card is still there. And I can query for the ID, postal code, bin, and it works. So this doesn't replace your validations or your permissionings. Like, you will always need to have app data to make sure that people have the correct permission to access certain business objects. However, this does make your API incredibly powerful and self-expressive. And now you don't have to duplicate as much business logic in both your front end and your back end, because your API understands the nature of your data. All right, I do want to touch on tests. I love it when Mott says he hates tests, because I also hate tests. And testing is hard. And if you imagine, if we wrote out all of those type classes, the tests are going to be incredibly repetitive, meticulous, not to mention error-prone, right? But if we metaprogram things away, we have one code path that we need to test. If the metaprogramming that generates our GraphQL type classes is correct, we have some assurance that it's going to be right. So this is just a quick and dirty R spec, and we first call it, and you're like, oh yeah, classes don't exist, and then we run it through our GraphQL type generator. That's basically our subject, and we go back through and be like, yep, there are instances of class, and we make sure that the names match. And I don't expect you to read this. I just want to prove that this can be tested. We add the fields, and we run through each of the fields and make sure, is the return type what we annotated it as, and is whether or not it can be null what we annotated it as. And it works. So to wrap up my talk, I want to revisit our checklist, right? Is our API flexible? Yes, this is in my very controlled prototype, but I do think it shows some potential that, yeah, it can adapt to changes in our data objects and the structure of our business. 2, clearly it reduces boilerplate. 3, is this self-documenting? Yeah, I think now you don't have to follow, here are those 8 REST endpoints, you get the super nested data. Your GraphQL API just gives you back exactly the shape you want. And 4th, is it improved developer experience? I would say just have to write a new test for each GraphQL type is an improved developer experience to me. So with that, I just want to say, I think metaprogramming kind of gets a bad rap because people use it in crazy ways. And I don't think I showed you any metaprogramming dark magic. Everything I used were pretty fundamental concepts. And I want to demonstrate here that metaprogramming, when used in an eloquent and isolated way for a specific use case, is actually kind of a great pattern. And also, I want to emphasize that GraphQL can exist in harmony with your REST. You don't have to go all in. Same thing with your metaprogramming. If you have something you just can't metaprogram it away, don't include it in your GraphQL type generator, right? You just leave those classes alone and run through the simple objects that can be metaprogrammed away through this generator. So things can work together. And finally, I'm going to do some resources. So I just basically read the docs to create my prototype. This metaprogramming book is surprisingly interesting. I was dragging my feet reading this, and it goes by fast. And finally, I would also like to thank the people on my team at Square. All the knowledge that I needed to create this prototype couldn't have been done without their mentoring. And also thank you, my audience, for listening to my talk. That's Nelly, by the way, in case it wasn't clear. And that's it. Thank you. It's a shark, actually. I can tell. It's blue water in the bottom, and then the shark, yeah. I can take questions. Yeah. Questions? Yes, because the actions in Square, that we use in Regular, are pretty straightforward. It's do a thing, and is it successful or not? And it may or may not even need metaprogramming, because it's like, freeze an account. Was it successful? Great. So I haven't explored that aspect of it yet. But mutations, as you know GraphQL pretty well, mutations are much easier than queries. So I think it is a possibility, and maybe by my next talk I can have something down for it. So you definitely have a question. Yes, sir. Yes, I'm going to push them up to my GitHub, I swear, by end of day. Oh, he asked if the slides are available online. Also, Tad asked if I was going to do, sorry, I meant to repeat all the questions. Tad asked if I was going to do metaprogramming for the mutations, which are the write paths. And I told him, yes, probably. Yeah. And because mutations are actually a lot easier than reads, so it has potential. Any other questions? Yes.
This is a generic GraphQL question. So I love the concept, but every time I try to introduce it at my current job,
it gets shot down?
The backend engineers are like, what if they go rogue and write a query that brings down production? Is there any
Yes. Yes. So GraphQL, I didn't get to this, but because it loads up the entire schema before each query, it has a lot of tracing by default. That the GraphQL Ruby gem does for you. So it does default limits, so it doesn't blow up, but you can also configure your own personal limits. So say, I do a nesting maximum of 10. If your query is beyond 10, because remember, it parses the query first, so it knows beforehand. Also, you can do tests where you can run what's called benchmarks on each query, and you can record that in your schema. If you're like, the benchmark's over 3.5 seconds, don't even execute. So it has a lot of potential. Also, another thing, so GraphQL is from Facebook, right? So Facebook doesn't actually send the queries back, because that's a lot of text for Facebook. What they do is they send an ID back, I believe. And the ID maps to a query that's saved on the server. And if the query is saved on the server, they know, okay, this query takes about anywhere between this and this long, so to make sure things don't blow up. Yeah, I think it's just like a usage, a different in verb usage. If I may go back to my slide where I have the bird's eye view of what it looks like. So when we ask for data, right, we are fundamentally traversing the graph, right, from the demo schema. Oh, he asks, sorry, did everyone hear that? He asked that, what he thinks, yeah, well, when it resolves, right, it looks at query type, and based on what query type has to offer, right, it's like, payment or merchant. And depending on that, it takes an action, right? And then it looks at payment type. And then depending on what it's associated with, which is ID, amount, and merchant, it takes on certain actions as well. So it looks at merchant and be like, well, there's more to resolve from that point on. I'm going to take an action where I go into my merchant type and resolve all of these fields. I think might be a difference in wording. Yeah. So Isaac, right, asked, what's the difference between GraphQL and SOAP? Because it reminds him a lot of SOAP. First up, disclaimer, I don't think I was alive for SOAP. So I actually know very little about SOAP. I wasn't alive, so that's no. But what I think is different is, I can only make guesses because I really just don't know stuff that well. It's like, well, it knows a lot of information about itself, and I'm sorry. Yeah. Yeah. I'm sure Facebook would love to explain the difference between GraphQL and SOAP to you. Like, it'll be all over. Yeah, it's behind him. So what he asked was, how do you deal with N+1 problems with GraphQL, and how to deal with multiple resources, right, from which you fetch your data. So I conveniently had no time to tell you about the downsides. We did initially run into a lot of performance issues, right, because it does load up the entire schema every single time. So we had to make sure that each resolve method was incredibly performant. And something else, if I may just go back to one of my slides again to point out, is that in these resolvers, you can put, so that's line 11 through 18. All right, you can put multiple resources through here. So what some people do is you don't even need this is like way off in the future. It's like you might not even need a server, because if you have a GraphQL layer, if payments comes from a payment service, you can put a direct client call to your payment service. If your merchant comes from your merchant service, put a direct client call to your merchant service. And you have two different resources, right? And then if you have, and GraphQL does this thing called schema stitching, where it takes schemas from two different resources and puts it together. And that's, I think, still a very experimental feature. And then it resolves and gives you your data back in the JSON. Well, I'll be here. You can ask me about GraphQL or the directions which you slice your bagels. And my dog.